we will start the differential equations topic. From beginning, we will see the one equation. I am taking y is equal to x square. It is an equation of parabola. If we take x is equal to 1, we'll get y is equal to 1. If we take x is equal to 2, we'll get y is equal to 4. If we take x is equal to 3, then y is equal to 9. So here we are choosing x values independently. So this x is called independent variable. This x is called independent variable, and y depends on x. So this y is called dependent variable. X is called independent variable and y is called dependent variable. Now if we differentiate this equation, y is equal to x square with respect to x, we'll get dy by dx, that is equal to 2x. Here in dy by dx, this x is called independent variable and this y is called dependent variable. And d by dx is called derivative. This is the derivative or differential with respect to x. So an equation which involves independent variables. Number one, independent variables, and number two, dependent variables, and derivatives with respect to one or more independent variables. Then that equation is called a differential equation. Once again, an equation which involves independent variables, dependent variables, and derivatives with respect to one or more independent variables, then that equation is called a differential equation. Okay. Now I'm taking one example here. Dy by dx. I'm taking here dy by dx plus
p of x.
dy by dx plus y is equal to e to the power of x. Here this is the independent variable, y is the dependent variable. So it contains derivative d by dx, so that it is an example of differential equation. And I'm taking another example, d square y by dx square plus 3 into dy by dx plus 2 into y is equal to e to the power of x. And this is also an example of differential equation. I am taking another example, dou square z by dou x square plus dou square z by dou y square is equal to x square plus y. And another example, dou square v by dou x square plus dou square v by dou y square plus dou square v by dou z square is equal to 0. We can observe here from first two examples. Here the independent variable is what? X. Here also the independent variable is x. In the second two examples, we can observe x and y. Both are independent variables and z is the dependent variable. In fourth example, here x, y and z, three are independent variable and v is the dependent variable. So we can classify or we can divide differential equations into two types. Mainly we can classify.
Sir, video not coming, sir.
Yeah, it's okay, madam. ఒకసారి మళ్ళీ మీరు లాగిన్ కండి, క్లోజ్ చేసి లాగిన్ కండి. It's 100% okay. Network is issue is there.
Okay, sir.
Right.
The differential equations we can classify into two types, mainly two types. First one is ordinary differential equation. Ordinary differential equation or equations. Simply we can call it as ODE. And second one is partial differential equation. Now we see the definition of ordinary differential equation. Here, ordinary differential equation, simply we can write it as ODE. So an equation, a differential equation which involving single independent variable. See, single independent variable. Such type of differential equation is called ordinary differential. Single independent variable means only one independent variable. For example, if you take dy by dx is equal to sin x plus cos x. Here x only is the independent variable, and I am taking another example, d square x by dt square is equal to minus kx. Here t is the single independent variable. These two are examples for ordinary differential equation. Simply a differential equation which involving single independent variable, that is only one independent variable. Such type of differential equations are called ordinary differential equation. Now, second type of differential equation is partial differential equation. Partial differential equation, a differential equation which contains two or more independent variables. Two or more independent variables. For example, I am taking dou square z by dou x square plus dou square z by dou y square is equal to x square plus y square. Here the x and y, these two are independent variables. So here two independent variables are there and contains partial derivatives. You have to remember one thing, partial derivatives. Dou by dou x, dou by dou y, like that. A differential equation which contains two or more independent variables and partial derivatives with respect to them. Such type of differential equations are called partial differential equation. Now, some types of partial differential equation. First one is dou square v by dou x square plus dou square v by dou y square plus dou square v by dou z square is equal to 0. This is an example of partial differential equation, and this differential equation is called Laplace equation. This differential equation is called Laplace equation. Now I am taking another example, dou square v by dou x square is equal to 1 by c square into dou square v by dou t square. Here x and t are two independent variables. This differential equation is called wave equation. Now this differential equation is also represented as dou square v by dou t square is equal to c square into dou square v by dou x square. This is also known as one-dimensional wave equation. One-dimensional wave equation. If we take a two-dimensional wave equation, that means the two-dimensional wave equation is in the form of two-dimensional wave equation. Wave equation is dou square v by dou t square is equal to dou square v by dou t square is equal to c square into dou square v by dou x square plus dou square v by dou y square. Here three independent variables t, x and y. This is an example of partial differential equation and it is known as two-dimensional wave equation. If we take a three-dimensional wave equation, that is three-dimensional wave equation is dou square v by dou t square is equal to c square into dou square v by dou x square plus dou square v by dou y square plus dou square v by dou z square. This is an example of partial differential equation, and it is the three-dimensional wave equation. Okay. Now, dou square v by dou t square is equal to, or dou square v by dou x square is equal to c square into 1 by c square into dou square v by dou t square. This is an example of partial differential equation, and it is called wave equation. Sorry, manaku jail lo adigaadu. Which of the following is the wave equation? Okay, different options we have. From the, we can select this one. Dou square v by dou x square is equal to 1 by c square into dou square v by dou t square. For more general, I am taking two-dimensional as well as three-dimensional wave equation. Okay, and another example for partial differential equation. Dou v by dou t, dou v by dou t is equal to some constant k into dou square v by dou x square. This is an example of partial differential equation which contains x and t are independent variables. This differential equation is called one-dimensional diffusion equation. Diffusion equation. Okay, we can take the two-dimensional diffusion equation. That is, dou v by dou t is equal to k into dou square v by dou x square plus dou square v by dou y square. This is the two-dimensional diffusion equation. Two-dimensional diffusion equation. And we can also take the three-dimensional diffusion equation, that is dou v by dou t is equal to k into dou square v by dou x square plus dou square v by dou y square plus dou square v by dou z square. This is the three-dimensional diffusion equation. Three-dimensional diffusion equation. Okay. Now we have to remember one-dimensional diffusion equation. From this we can generalize the two-dimensional as well as three-dimensional diffusion equation. I am taking one more special partial differential equation, that is del square v is equal to minus 4 pi rho g. Okay, which of the following is the Poisson equation అని అడిగాడు question, where del square v equal to, where del square is equal to Laplacian operator, that is dou square by dou x square plus dou square by dou y square plus dou square by dou z square. Okay, this is the Laplacian operator, where g is the gravitational constant, and rho is the mass density function. If mass density function is 0, that is, if rho is equal to 0, then the equation becomes del square v is equal to 0. Del square means dou square by dou x square plus dou square by dou y square plus dou square by dou z square into v equal to 0 means it becomes Laplace equation. That means we have one bit here. If the mass density function of a Poisson equation is 0, then Poisson equation becomes Laplace equation. These are the examples of partial differential equation. We have to remember all these equations. Okay? Now I am taking another topic, order of a differential equation. Order and also degree. Order and degree of differential equation. Okay, first to see the definition of order of a differential equation. The order of the highest order derivative. The order of highest order derivative. Highest order derivative involved in a derivative involved in a differential equation is called order of differential equation. Simply we can write the maximum derivative of a differential equation is called order of differential equation. And degree of a differential equation, the power of highest order derivative, highest ordered derivative is called degree of a differential equation. Okay, ఇక్కడ నుండి మనకు బిట్ అడగడానికి ఛాన్స్ ఉందండి. ఆర్డర్ అండ్ డిగ్రీ మీద ఒక సింగిల్ బిట్ రావడానికి ఛాన్స్ ఉంది. ఐఎమ్ టేకింగ్ సమ్ ఎగ్జాంపుల్స్ ఫ్రమ్ ప్రీవియస్ JL, PL, junior lecturers, polytechnic lecturers, GATE and JAM, and also from JL. Okay, first one by one I am taking. I am writing the question here. The order and degree, of the differential equations. Okay, one by one I am taking. First, d square y by dx square plus y into dy by dx is equal to sin x. Here the maximum derivative is 2, so that order is equal to 2, and the maximum derivative power is 1, so that degree is equal to 1. And I am taking another example. V plus m into dv by dm is equal to v. V plus m into dv by dm is equal to v square. Here the maximum derivative is 1, and its power is also 1. So order is equal to 1, and also degree is equal to 1. And another example, d square y by dx square whole square plus dq y by dx cube is equal to e to the power of x minus x. Here order, the maximum derivative is 3, that is the order, and degree, we see the maximum derivative power, it is 1, so degree is equal to 1. And fourth example, d square x by dt square plus k into x is equal to 0. So the maximum derivative is 2, that is order is equal to 2, and its power is 1, so degree is equal to 1. And another example, taking next page, dou square v by dou t square is equal to c square into dou square v by dou x square. This is the fifth example. Here order is equal to 2, and degree is equal to 1. Okay, ఇదే క్వశ్చన్ ఎలా అడగడానికి ఛాన్స్ ఉందంటే, the order of the, what is this equation? Dou square v by dou t square is equal to c square into dou wave equation. Okay, so the order of the wave equation is, ఇలా కూడా క్వశ్చన్ అడగడానికి ఛాన్స్. Okay, and I am taking another example. y is equal to root x into dv by dx, dy by dx plus k into dy by dx. First, we can simplify this equation as y into dy by dx is equal to root x into dy by dx whole square plus k. So here maximum derivative is 1, that is order is equal to 1, and the maximum derivative power is 2, so degree is equal to 2. I am taking another example. D square y by dx square is equal to 1 plus dy by dx whole to the power of 3 by 2. Okay, ఇలా fractions ఉన్నప్పుడు we need to eliminate those fractions.
Square on both sides.
One second. Now we need to eliminate the fraction. So squaring on both sides will get d square y by dx square whole square is equal to 1 plus dy by dx whole to the power of 3. Okay. Here the maximum derivative 2, so order is equal to 2, and maximum derivative power is 2, so degree is equal to 2. Okay. I am taking another example. Y is equal to x into dy by dx plus k into under root of 1 plus dy by dx whole square. This is the differential equation. First, we have to eliminate the square root. So for this, I am rearranging this equation into y minus x into dy by dx is equal to k into square root of 1 plus dy by dx whole square. Okay. By squaring on both sides, we'll get y minus x into dy by dx whole square is equal to k square into 1 plus dy by dx whole square. Okay. So while expanding y minus x dy by dx by using a minus b whole square formula, we'll get dy by dx whole square term, not d square y by dx square term. So the order maximum derivative is 1 and its power should be 2. So order is equal to 1 and the degree is equal to 2. And I am taking another example. D cube x by dt cube plus d square x by dt square plus dx by dt whole power 4 is equal to e power t. So here the maximum derivative is 3, order is equal to 3, and maximum derivative power is 1, not take don't take 4 value. Okay, so here degree is equal to 1, order is equal to 3, and degree is equal to 1. And I am taking another example. D square y by dx square is equal to y plus dy by dx whole power 6 whole to the power of 1 by 4. First, we need to eliminate the fraction 1 by 4. So we can write this equation into d square y by dx square whole power 4 is equal to y plus dy by dx whole power 6. So for this differential equation, the maximum derivative is 2, that is order is 2, and its power is 4, that is degree is equal to 4. Now I'm taking one recent JL question. The degree of the I'm writing here. We said JL, the degree of the differential equation. 1 plus dy by dx whole square whole power 3 by 2 is equal to k into d square y by dx square. This is the question. First, we have to find the order, then we can easy to find the degree. Okay. First, we declare the fraction 3 by 2. That is, we can write this differential equation into 1 plus dy by dx whole square whole power 3 is equal to k square into d square y by dx square. So here the maximum derivative is 2. So order is equal to 2 and its power is 1. Sorry, it is square. It is square. Okay. This power is 2. So degree is equal to 2. Order and degree is equal to. This question manaku JL lo different DL lo different ga adigadandi. The degree of the differential equation. The degree, same question but different. DL question. The degree of the differential equation P is equal to 1 plus y dash square whole power 3 by 2 divided by y double dash is. Here y dash square, not y power 1 2. Y dash means dy by dx. Y double dash means d square y by dx square. It is a formula for radius of curvature. So first we can write this equation into p into y double dash, that is equal to 1 plus y dash square whole power 3 by 2 and squaring on both sides we get to p square into y double dash whole square is equal to 1 plus y dash square whole power 3. So their maximum derivative is 2, that is order is equal to 2, and the maximum derivative power is 2, that is degree is equal to 2. Okay, this is the DL question and this is the JL question. And I am taking another question from Polytechnic lecturers PL. The degree of the differential equation y is equal to x into dy by dx plus a into 1 plus y dash is. Here y dash means dy by dx alone. Dy by dx is the same. So the maximum derivative order is 1 and its power is 1. So degree is equal to 1. Okay, manali degree maatrame adigadu. Degree is equal to 1. And another question I am taking from JL. If n and m denote the degree and order respectively of the ordinary differential equation of the ODE d power 4y by dx power 4 plus d square y by dx square plus dy by dx whole power 5 is equal to e to the power of x. then ordered pair n comma m is equal. Okay, this is the question. Now, first n denotes the degree and m denotes the order. So order, I'm writing first order m is equal to maximum derivative is 4. So order m is equal to 4, and degree is n, that is the maximum derivative power, that is d power 4y by dx power 4 power is 1. So degree is equal to 1. But we need to find a n comma m, that is 1 comma 4. This is the order pair n comma m. I'm taking another example. The order of the differential equation, it is from PL, Polytechnic Lecturers. The order of the differential equation of the family of circles, of variable radius small r, with centers on the x-axis. The centers on the x-axis is, we have to find the order, okay, maximum derivative of the differential equation. Now the equation of circles having radius r, center on the x-axis. Actually, the equation of the circles having center h comma k and radius r is x minus h whole square plus y minus k whole square is equal to r square. But the center lies on the x-axis, so h comma 0, y coordinate is 0. So this equation becomes x minus h whole square plus y square is equal to r square. Here we have one parameter h. So this is the arbitrary constant. So order is equal to 1. Okay, have to remember order of the differential equation. Is equal to number of arbitrary constants. Here we have one arbitrary constant h. So order is equal to, okay, ఇలా x యాక్సిస్ అడగకుండా మనకు జనరల్ గా ఇచ్చాడు అనుకోండి, అప్పుడు ఈక్వేషన్ ఏ ఫామ్ లో ఉంటుంది, x minus h whole square plus y minus k whole square equal to r square ఫామ్ లో ఉంటుంది. ఇక్కడ 2 ఆర్బిటరీ కాన్స్టెంట్ h and k ఉన్నాయి కాబట్టి h comma k are arbitrary కాబట్టి so that time order is equal to 2 arbitrary constants. Okay, you have to remember order of the differential equation is equal to number of arbitrary constants. I am taking one example. The order of the differential equation, sorry, I am taking, okay, if y is equal to, is from JAM, if y is equal to a into e to the power of bx plus c, then order of the corresponding differential equation, corresponding differential equation is, okay, actually మనం ఇక్కడ చూస్తే 3 ఆర్బిటరీ కాన్స్టెంట్స్ కనబడుతున్నాయండి. ఆ 3 కాదు, ఇక్కడ దీన్ని ఎలా రాసుకోవచ్చు అంటే y is equal to a into e to the power of bx into e to the power of c. So y is equal to a arbitrary, e to the power of c is also arbitrary because c is an arbitrary. So a into e to the power of c is again an arbitrary constant, call it as d, e to the power of bx. Here we have two arbitrary constants d and b. So order is equal to 2. Okay, order is equal to 2. And I am taking another example, from gauge. This from gauge. The order of the differential equation. The order of the okay. The order of the differential equation by eliminating the arbitrary constants. By eliminating the arbitrary constants. Arbitrary constants from the equation, or from y is equal to c1 plus c2 sin square x plus c3 cos square x plus c4 sin 2x. This is the differential equation. Okay, this is the equation. We have to find the order of the corresponding differential equation. Okay, but we have options here. First, option A 3, option B 2, option C 1, option D 5. These are the options. But when I choose C1, C2, C3, C4, 4 arbitrary constants. Now, then simplify చేసుకో. Y is equal to C1 plus C2 into sin square x can be written as 1 minus cos 2x by 2 plus C3 into cos square x can be written as 1 plus cos 2x by 2 plus C4 sin 2x as this. Okay. So we can write y is equal to C1 plus C2 by 2 plus C3 by 3. We are writing 1. C1 by 2 plus C3 by 2 constant terms. And we can take cos 2x common here. So here we have C3, here we have minus C2. This is the cos 2x coefficients. And C4 is the sin 2x. Okay. So y is equal to, this is nothing but arbitrary constant, single arbitrary constant. Call it as capital A. And this is another arbitrary constant B, cos 2x, and C, where C4 is the another arbitrary constant sin 2x. Here, order, arbitrary constants are 3. So order is equal to 3. Okay. ఇలా ఎందుకు మనం సింప్లిఫై చేసామంటే ఇక్కడ 1, sin 2x, cos 2x. These 3 solutions are linearly independent solutions. These 3 are linearly independent solutions. Okay. Now we can remember one point here. Order of the differential equation, or simply I am writing, generalizing the nth order linear differential equation as exactly n linearly independent solutions. That means order of the differential equation is equal to, another point, order of the differential equation is equal to number of linearly independent solutions. number of linearly independent solutions. You have to remember this. First point ఏం చెప్పుకున్నాం, order is equal to number of arbitrary constants and order of the differential equation is equal to number of linearly independent solutions. I am taking one question from GATE. It is from GATE. The order of the differential equation. Sorry. Next page. The maximum number of is from GATE. The maximum number of linearly independent solutions of the differential equation d power 4y by dx power 4 is equal to 0 with the condition y of 0 is equal to 1. Y of 0 is equal to 1 is, okay, first option A 4, option B 3, option C 2, option D is 1. These are the 4 options. As we know that number of linearly independent solutions is equal to order of the differential equation. So yes, order of this differential equation is 4. Order is equal to 4. Order is equal to 4 means number of linearly independent solutions. So option A is the right option. మరి ఏంటి ఆ లీనియర్లీ ఇండిపెండెంట్ సొల్యూషన్స్ ఏంటి? ఓకే, డీటెయిల్ గా చూద్దాం. ఫస్ట్ we take the equation d power 4y by dx power 4 equal to 0. This can be one time integration, we'll get dqy by dx cube is equal to some arbitrary constant 0. Okay, again integrate, we'll get d square y by dx square value, that is c1x plus c2. Again differentiate, we'll get dy by dx value, that is equal to c1 x square by 2 plus c2x plus another arbitrary constant c3. Okay, again integrate, we'll get y is equal to c1 x cube by 6 plus c2 x square by 2 plus c3x plus c4. These are the solution. Y means here y of x. We are given the boundary condition y of 0 is equal to 1. Replace x by 0 and equating to 0, we'll get first term 0, second term 0, third term 0 plus c4 is equal to 1. That is c4 is equal to 1. And substitute c4 value here in this. So we get y of x is equal to c1 by 6 x cube plus c2 by 2 x square plus c3 x plus 1. So here x cube, x square, x and 1 are linearly independent solution. That is 1 comma x square comma x cube. These are the linearly independent solutions. Okay, so number of linearly independent solutions are 4. Okay, now I'm taking another important point here. Sir, shall I stop today, sir?
Sir, thank you, sir.
Okay, if you have any question, you can ask. Please ask the participants.
Any questions from this topic?
You can ask. Yes.
Sir, hello sir.
Yes, sir. చెప్పండి మేడం.
Sir, one-dimensional heat equation or diffusion equation, both are same, sir?
Yes. Heat equation is also known as one-dimensional diffusion equation. Both are same. Okay, అక్కడ చెప్పండి. Heat conduction equation ఇంకా డీటెయిల్ గా దాన్ని హీట్ కండక్షన్ ఈక్వేషన్ కూడా అన్నారు. This is the where it is. This is okay. This is heat conduction equation కూడా అన్నారు.
మళ్ళీ మీకు ఈ నోట్స్ పీడిఎఫ్ పంపిస్తారు మేడం.
ఇది యాజ్ ఇట్ ఈస్ గా మీకు పంపిస్తానండి.
మళ్ళీ మీకు యాజ్ ఇట్ ఈస్ గా ఎక్కడ మిస్ అయినా కూడా మీరు నోట్ చేసుకోవచ్చు.
నోట్స్ ఉన్నదని మీరు మళ్ళీ అడగండి.